Hi there. So in this video, I'm going to do the last 15 questions from that multiple choice set. These were the calculator active problems. And I won't be showing you my calculator, but I'll try to talk through what I did. If you have any questions about specific calculator techniques, please talk to me. So problem 31 here. Particles moving along a straight line and velocity is given. S is position, its distance from the origin. So we're told that the position is 1 when time equals 0. So when time equals 1, what is S? So the way you should think about this is, oh, actually, this is a trick. So let me take that back. So what we have here is that the rate at which position changes is 12 times the square root of position. This is not velocity as a function of t. It is describing how velocity is related to position. So this is a differential equation to be solved. So by separation of variables, I would have s to the negative 1/2 ds equals 12 dt. Integrate. So here s to the 1/2 with a 2 in front of it. Here 12t plus c. If I plug in my initial condition when s is 1 when t is 0. So I would have that s is 1 while t is 0, so c is equal to 2. So our formula here is that 2 times the square root of s is 12t plus 2. So we want to know what s equals when t equals 1. So 2 times, I'm not even bothering to solve for s. We just have 2 times the square root of s is 12 times 1 plus 2, which is 14. So root s equals 7, and s is 49. For number 32, we're told that this sketch shows the graphs. So we have the graph of this parabola and a vertical line at x equals k. When do these regions have equal areas? So these regions have equal areas if the integral of this function is 0, because this area counts negative in an integral, this area counts positive. So what we actually want is that the definite integral from this x-intercept, and you can quickly figure out that that's negative 1, to k of x squared minus 4x minus 5, we want that to be equal to 0. And we want to solve this for k. So in theory, you could do fundamental theorem of calculus. What you can actually do is you can use numerical solve here. Your calculator can handle this. So the way you would do this is, I'm just going to talk through. But from your calculate menu, it's in the algebra thing. So let me write out what I would type out. So n solve and then the first thing you put in is this entire equation. So that does require some typing, but this is still the fastest way. So you would use the definite integral on your calculator and everything. Make sure you're careful where are your k's and where are your x's. So I am typing this in as I explain it to you. Definite integral from negative 1 to k of x squared minus 4x minus 5 dx, and I'm saying that's equal to 0. So you write the equation, then comma, then the variable you're solving for, we're solving for k. Then what's optional but is helpful is you give it a range to look at. So this second x-intercept happens at 5, and we're not exactly sure what this is, but I could say, hey, let's look for a solution between 5 and say 15. So you could put in those two. Those are optional, but they help guide the calculator where to look because there might be more than one solution. So comma 5, comma 15. And the calculator will give you an answer of 8. Now, sometimes what I'm getting here is it gives you a warning that it's not sure if that's super duper accurate. I will tell you honestly, I don't see this as an actual problem you would see on the AP. I don't know if they really want you putting this in your calculator, but the other way is a little too long to be a reasonable problem. Okay, 33. Bacteria in a culture increase at a rate proportional to number present. So you should see that. Oh, when something increases proportional to how many there are, that's proportional growth, which is exponential growth. So the initial population of 200 triples in 10 hours. If this if this continues, what will it be after 1 day? So basically we have that we're starting with 200. So the number of bacteria is 200 times e to the kt. We're starting with 200 and it's exponential. Again, I don't know how realistic this is as a problem that's actually AP, but they do want you to know this general thing that proportional growth is exponential. It has an exponential type function. You don't want to stop and solve that differential equation. So B of 10 is 3 times as much. It says it's triples. So e to the 10k is 3. 10k is the natural log of 3. So k is the natural log of 3 divided by 10. So after 1 day, B of 24 would be 200 times e to the natural log of 3 over 10 times t, which is 24. So you can put that in your calculator. Remember, e to a power is its own button. Don't type in the number e. Don't type in the letter e. And I get about 2793, which is C. All right, 34 is an abstract problem about U substitution. So it says when we make that substitution, what are we going to have? So let's highlight what's going on here. So in the original integral, those bounds are on x. And u is t minus 1. But they're saying x, sorry. The original integral has a variable called t, and we're doing it what's a u substitution, but they're asking you to call it x. So if t equals 3, x is 5. If t equals 5, x is 9. So right off the bat, we know we're looking for an integral from 5 to 9. That rules out 2 of them. Now, what's the rest of this going to look like? So if x is 2t minus 1, then dx over dt is 2. So dx is 2 dt. So let's make all of the relevant substitutions. My integral now goes from x equals 5 to x equals 9. What is t? So this is a tricky kind of substitution that I think shows up rather rarely on the AP. X plus 1 is the same as 2t. So t can be written as x plus 1 over 2. So we have x plus 1 over 2 times the square root of x. And then dt is 1/2 of dx. So to put it in this form, what we'll notice is they're taking the constant and moving it out front. So I have a 1/2 and a 1/2 that get moved out front. So in their form, this would be the same as saying, oh, I'm multiplying by 1/4 and I don't have those halves anymore. So our choice here is B. I think it's a little weird that they ask you to give KAB instead of just writing the 4 integral expressions. Some of these Barron's problems are a little quirky. All right, question 35. If you do this the quote-unquote official way, it takes a ton of time and is much harder than we would expect. I will tell you, your calculator can graph relations. So if you go to your graph, and one of your options is under graph, you usually pick function, but you can graph a relation. And you can just type in how x, and you can type in this whole equation. X cubed plus x times y. Make sure you put in a multiplication there because sometimes it'll think that you're naming something xy. So you do have to literally write x times y. So you can just write in this equation. And you'll see that there is a vertical tangent. And what you can just do is keep zooming in, right? This is not the way they're planning for you to do it, but it would work out. So if I just continually zoom in on this, and you can't really see what I'm doing, but I see, yeah, unfortunately you can't get the right resolution. So I tried that. The official way to do this, and this is one of these problems that's much harder than you would be asked to do in 3 minutes. But vertical tangent line means the derivative is undefined. So we can use implicit differentiation to figure out what dy dx is. Product rule here, so derivative of the first times the second plus the first times the derivative of the second. Chain rule for the derivative of y squared. So we would have that dy dx times x minus 2y is equal to negative 3x squared minus y. So our derivative, if we use implicit differentiation, can be written like so. This would be undefined if x equals 2y. So on the one hand, we're looking for the place where x equals 2y. On the other hand, it's on this curve. So we could make a substitution. I'll squeeze this in up here. X equals 2y means I have 8y cubed plus 2y times 2, so that's 2y squared, minus y squared is equal to 10. So we have 8y squared plus, 8y cubed plus y squared equals 10. And you could numerically solve that on your calculator. Hopefully you're realizing this is way too much for a real problem. Barron's book, some of the problems were so great, and I'm realizing that some of them are really not good at all. But if I do numerical solve on that, 8y cubed plus y squared equals 10. Solve that for y. I get that y is equal to 1.037, which they have waiting for you, but they ask what x is, and x is twice that. So twice that is c. Really quite an ordeal of a problem. I don't think this is a realistic thing to expect. All right, let's look here. All right, so just when I read this, right, this is the graph of f, but they give me this. So I know this is like fundamental theorem of calculus, but it's a little bit trickier because that's not x. By chain rule, what I know is that g prime would be f of that thing at the top, and then by chain rule times the derivative of that. So there is a little wrinkle here, but whenever you see a function defined using a definite integral, think about what the fundamental theorem of calculus says about its derivative. So what are they asking? What's g prime of 1? So g prime of 1 would be f of 2 times 3. F of 2 is 2, so that is 6. And then where does g have a local maximum? So g has a local maximum when g prime switches from positive to negative. This is one of these things, don't even look at the graph yet. Just say, what will I be looking for? I will be looking for g prime switching from positive to negative. So I want to know, where does this switch from positive to negative? The 3 doesn't affect whether it's positive or negative. So we'll notice that f of x makes the switch from positive to negative when x is equal to 3. So f of 3x minus 1 would make the switch when 3x minus 1 is equal to 3. So 3x equals 4 and x is equal to 4/3. When x is equal to 4/3, the thing we're taking f of is 3, and therefore we have a switch. So 37 is B. All right, 38, they give you a table, and they ask you to find this limit. So our first instinct with any limit problem would be to just plug in. If I plug in, what do I have? F of 2 is 6, plus 3 times g of 2 would be 3 times negative 2, which is negative 6. In the bottom, 1/2 times 2 squared is 2, minus 2 times e to the 0. This is 0 over 0. So hopefully a little bell goes off. Oh, 0 over 0 as a limit of a fraction. Let me do L'Hopital's rule. By L'Hopital's rule, I can now say, let's take the limit as x approaches 2 of the derivative of the top over the derivative of the bottom, which would be x minus 2e to the x minus 2 times 1 by chain rule, but we're kind of safe there. So now, what do we get if we plug in there? If we plug in there, f prime of 2 is negative 1, plus 3 times g prime of 2, so that's plus 3 times 1/3, which is 1. In the bottom, we have 2 minus 2. It's still 0 over 0. Okay, so this is an interesting problem, but probably longer than a real AP multiple choice. By L'Hopital's rule, I can do it again. Take derivatives one more time. I would have f double prime of x plus 3 times g double prime of x over 1 minus 2 times e to the x minus 2. So now if I plug in, I get negative 2 plus 3 times negative 4/3 over 1 minus 2. So what do I have? Up top, that is negative 2 minus 4. In the bottom, that's negative 1. That looks like 6, and that is correct. All right, 39 is asking us to use left rectangles and 4 subintervals of equal width to estimate this integral, and we'll notice it's an absolute value. So I'm going from 0 to 8, so I break it up every 2. My first rectangle is like this. My second rectangle, well, left endpoint is already there. My second rectangle is completely flat. My third rectangle is like this, and my fourth is like this. Now let's keep in mind, right, so I'll shade it. Right, the second one doesn't even matter. This is absolute value. So that means we're counting all the heights as positive, whether they're negative or not. Integrating the absolute value of this gives the true area between the graph and the curve, not the net signed area. So this rectangle here is 2 times 3. This rectangle here has an area of 0. This one is 2 times, well, the height is negative 4, but the absolute value turns that into 4. Here this is 2 times 1, right? That height of negative 1, the absolute value turns it into 1. So it looks like we've got 6 plus 8 plus 2, which is 16. So 39 is D. All right. What do we got here? Some information about f, and they're asking for the second derivative of f squared of x. So this notation is not particularly standard. I don't think they would spring that on you on the AP. But I will tell you f squared of x just means f of x squared. It's like sine squared. So what have we got here? So basically I have y is f of x squared. So if I take the first derivative of that, by the chain rule, that's 2 times f of x times f prime of x. If I take another derivative, there's a 2 on the outside, by product rule, derivative of the, derivative of the first times the second, plus the first times the derivative of the second. I think this is a very reasonable problem, except for that weird notation. So they want to know what is the value of that second derivative of this thing when x equals 3. So if I plug in x equals 3, I have 2 times, well, f prime of 3 is 5, so I have 5 times 5. F of 3 is 2, f double prime is negative 2. So this looks like 2 times 25 minus 4. So that's 2 times 21, which is 42, which is D. Right, the answer is 42. Okay. Here we have a velocity function. And it says, find the acceleration when the object is at rest. So, there are kind of 2 layers to this. First is, well, when is this at rest? That means the velocity is equal to 0. If the natural log of something is 0, that something was 1. So t squared is equal to 1. We're only talking about positives. So the when here is at t equals 1. So now let's take a derivative. One over that thing times by chain rule. We get that. So if I plug in 1,
I'll see you next year.
we have 1 over 1 times negative 2. Negative 2 is A.